Welcome back to Inspire AI, the podcast where we explore the ideas shaping our future with artificial intelligence. I'm your host, Jason McGinty. Today we're stepping into one of the boldest frontiers of all, quantum AI. In the long arc of human history, there are moments when the very foundations of knowledge shift, when what was once unimaginable suddenly becomes possible. Fire, the printing press, electricity, the internet. Each of these breakthroughs reshaped society, expanding what humans could achieve. Today, we stand at the threshold of another such transformation, the union of quantum computing and artificial intelligence. Picture this, a world where your AI assistant can instantly simulate every possible outcome of a business decision, or where scientists design a life-saving drug in hours instead of years. That's the promise of quantum AI, a fusion of quantum computing and artificial intelligence. But here's the real question. Is this the revolution we're waiting for, or is it just the brightest new piece of hype? Let's find out. In order to begin this story, let's start with the basics. Artificial intelligence, we all have an idea of what that is. It's about learning from data, spotting patterns, making predictions. But the story of AI actually begins in the 1950s, when researchers first asked a bold question. Could machines simulate human intelligence? Back then, early AI systems were rule-based and fairly limited. They could follow instructions, but not really learn. Fast forward to the 1990s, and the rise of machine learning breathed new life into AI. Then came deep learning in the 2010s, unlocking breakthroughs in speech recognition, image processing, and natural language understanding. Why the sudden leap? A lot of it came down to hardware. Faster GPUs gave us the raw computing power to train massive models. The large language models we use today are only possible because of those improvements. Now let's shift to quantum computing. This field is built on the strange but powerful principles of quantum mechanics, the physics of the tiniest particles in the universe. The big difference between traditional computers and quantum computers is that traditional computers use bits that are either 0 or 1. Quantum computers use qubits, which can be 0, 1, or both at the same time, thanks to something called superposition. Add in entanglement, where qubits become linked in ways classical bits never could, and suddenly you've got a machine that can explore solutions far beyond what a normal computer can handle. The idea of a quantum computer was first proposed back in the 1980s, but practical progress has only accelerated in recent years. Companies like IQM Quantum Computers are already building quantum machines designed to tackle problems classical computers struggle with. Things like optimizing global shipping routes or simulating new drugs. Now here's a term you'll want to remember: quantum advantage. That's the point where a quantum computer can outperform a classical computer on a commercially useful task. We're not quite there yet. We're still in the proof of concept stage. But the progress in the past decade has been dramatic. Some roadmaps, like IQM's, suggest we could see this breakthrough as early as 2030. In the meantime, we're already seeing hybrid systems, where quantum computers work alongside supercomputers in high-performance computing centers. So even though it's early days, the first wave of industrial adoption is happening right now. Now, why does this matter for AI? Because AI is hungry for computation, for optimization, for data. And quantum offers a whole new way to feed that hunger. Put the two together, AI's pattern finding power and quantum's ability to explore countless possibilities at once, and you get quantum AI. And that matters because today's AI, as powerful as it feels, has limits. It devours energy and data, gets stuck on certain optimization problems. It often works as a black box, making decisions we don't fully understand. And there are problems, like simulating the behavior of complex molecules that even the fastest supercomputers can't touch. That's where quantum could come in. Think of it as building a new kind of engine for AI, one that can take us farther, faster, into spaces we simply can't reach right now. So, how exactly could quantum help? Well, let's take training an AI model, for instance. Right now, it can take weeks and racks of powerful GPUs. A quantum computer, in theory, could handle some of that heavy math much more efficiently, shrinking training time dramatically. Or think about optimization problems. In AI, you're constantly tweaking parameters, tuning models, searching for that best fit. Quantum algorithms, like the wonderfully named quantum approximate optimization algorithm, could explore those possibilities in ways classical computers just can't match. There's also data processing. Imagine trying to classify or cluster mountains of information, like genomic data or financial transactions. Quantum methods should be able to spot patterns faster and more accurately. And here's the big one: scientific discovery. Quantum AI could help to simulate molecules for new drugs, discover materials for clean energy, or solve logistics puzzles on a global scale. If classical AI is like walking every street of a city one by one, quantum AI is like flying overhead and seeing all the paths, all the streets at the same time. But here's a twist that doesn't get talked about enough: AI doesn't just benefit from quantum, AI actually helps quantum too. This symbiotic relationship where we know quantum computers are fragile. They need perfect calibration. They suffer from noise. They make errors. That's where AI steps in. Machine learning can automatically calibrate quantum hardware, keeping it running smoothly. It can detect and even correct errors in real time. It can help design smarter quantum algorithms, basically teaching the computer how to get more reliable results. And in the long run, AI might even help design better quantum chips themselves, creating processors that are more efficient and less error prone. So, really, it's a partnership, a symbiotic relationship. Quantum amplifies AI, and AI strengthens quantum. Each helps the other grow. Now, let's be clear: we're still in the early days. Quantum AI hasn't yet delivered a quantum advantage for real world AI tasks, that magic moment where it outperforms the best classical computers. Most of what we've seen so far are experiments. The hardware is delicate, the systems aren't scalable yet, but momentum is real. Big players like Google, IBM, Microsoft, alongside startups and labs around the world, are investing heavily. Hybrid systems, where quantum and classical computers work side by side, are already being tested. And forecasts suggest that by 2026, nearly one-fifth of the revenue of quantum algorithms could come from AI applications. So is it hype? Not entirely. It's more like we're in the 1980s of the internet era. Clunky, experimental, not obviously life-changing yet. But the foundation is being laid for something extremely transformative. And here's why it really matters. At the end of the day, quantum AI isn't about the machines. It's about us, humans, expanding what we're capable of. Imagine a future where quantum AI helps design a cure for Alzheimer's, or where global supply chains can adapt instantly to a crisis like a pandemic, or where climate models become so precise that they can actually guide meaningful, sustainable action and see far into the future. That's the kind of future we're talking about. But like Uncle Ben says, with power comes great responsibility. With these breakthroughs, we'll need to think deeply about privacy, security, ethics, and fairness, long before the technology matures. So where does that leave us? Quantum AI isn't just hype, but it isn't there at scale yet. What it is possibility. We're watching two of the most powerful technologies of our time, quantum computing and artificial intelligence, learn to dance together. And that partnership could define the next era of human progress. We stand at a rare crossroads in history where two of the most powerful forces of human innovation, artificial intelligence and quantum computing, are beginning to converge. Separately, each is revolutionary. Together, they may reshape everything we know about science, technology, and ourselves. The breakthroughs to expect are vast. AI models trained in hours instead of months. Drugs designed with atomic precision. Materials engineered for sustainability. Languages understood with true nuance. And mysteries of the universe brought into focus. But beyond these achievements lies something deeper. A new relationship between humanity and the cosmos, between intelligence and the laws of nature. Quantum AI is not simply a tool. It is a mirror, reflecting both our capacity for wonder and our responsibility to wield knowledge wisely. The night sky once inspired us to invent astronomy, telescopes, and space travel. Today, the strange quantum fabric of reality inspires us to invent new kinds of intelligence. What breakthroughs await may be beyond prediction. One truth remains certain. The union of quantum computing and AI is not just a chapter in human progress. It is the opening of a new era. The real question isn't, what can quantum AI do? It's, what will we choose to do with it? And that's it for this episode. Thanks for joining me today on Inspire AI, brought to you by AI Ready RVA. Join us by staying curious, keep asking bold questions, and remember, the future isn't something we wait for, it's something we create.